Okay, we're back, we're live, we're at Think Tech Talks, and here in the 3 to 4 hour block on Thursday, we're talking with our chief scientist, the chief scientist of Think Tech for at least 10 years now, I think so. Has been Mike Deweert. We're here to talk today about Science this Thursday, because in a week or two, Mike is going to start acting as a host for this program, and at least the working title is Science Thursday.
Yeah.
So we'll see what happens, and it's a 1 to 2 block on Thursday, as I recall.
1 to 2. That's what I recall.
1 to 2 block every Thursday. So you'll see a lot more of Mike, and you'll see a lot more of science. And the idea is to introduce you to things in science that you would not otherwise have known about, or have studied in school, actually, unless you were a scientist yourself. We want to introduce you at Mike's level. He's going to talk turkey about science. And today, because it seems to be the topic of the hour, and maybe the topic of the hour for many years to come, we're going to talk about climate change and storms. And in fact, Mike is going to talk about a book that he has on the table. You can hold it up for them. It's called Storms of My Grandchildren. Yeah. And you can get the idea what that means. Anyway, thank you for coming on the show.
Thank you, Jay. Yeah.
Great to have you here.
Yeah.
So, the news is about the Vortex. What in the world is that? How does it work scientifically?
So we have this anomaly that's happened where they call a meridional flow has come down from the Arctic and brought very, very cold, frigid air deep into the continent. Now, normally in the winter in the Arctic, the air cools. You get a low pressure area, and air from south wants to move north. And as it moves north, it is affected by the Coriolis circulation, starts to go around the pole of the planet. And what's happening with the Arctic, because there's less ice on the Arctic Ocean, less ice to reflect the sunlight in the summer, less ice to insulate the water in the winter, the Arctic Ocean is absorbing heat from the sun and storing it. 96% of the light that falls on the ocean stays in the ocean, its heat, until the air cools and it comes out again.
That means the water gets warmer.
Yeah, the water gets warmer, and so now the energy that's stored in the Arctic Ocean is warming the pole. Now the pole is still brutally cold compared to what we're used to, but warming that pole reduces how low the low is up there, and that lets the air start leaking out of the pole in a sometimes chaotic and unpredictable way. And that's what we have had happen to us in the last week, where they've gotten this leakage of this air that's normally confined by the low pressure system at the pole, leaking out and freezing people.
Yeah. Before I forget, by the way, if you want to join the conversation, make a comment or ask a question to Mike Deweert, our chief scientist, feel free to do that by tweeting ThinkTechHigh at ThinkTechHigh. And we'll be able to see that right here, and we'll be able to pose those questions and comments to him. So, one thing, you talk about, it sounds like it creates a kind of instability, what we're talking about. And an instability can go in any direction.
Oh, yeah.
And it's not like you can say, well, okay, now we're going to have, cold or warm, or it could be a storm or no storm, or a storm here or there. It's anything goes.
Absolutely, because a few weeks ago, they're talking about record highs in North Carolina. It was in the 70s, and it was like unprecedented high, and now it's unprecedented cold. And you can conceive of in January, when they look at the whole month, maybe the average temperature won't be that different from the average of years past. But now we have 40 dead people because of the cold snap.
Yeah.
That wouldn't have been dead if it had been an average kind of year.
Yeah. Yeah.
So these extremes of variability in the climate are a consequence of the climate change that humans are largely responsible for. And it's only going to get worse and more extreme with time.
Yeah, I want to talk about that. The intensity.
Of the book. Yeah.
You got to get a book review going. Yeah. But it strikes me that when we say that it's unstable, that it's unpredictable, as never before. I mean, that's really an interesting place to be, having weather be unpredictable. But what's also unpredictable is severity.
Yeah. Yeah. So we've had the largest typhoon ever to make landfall hit the Philippines. 4th largest typhoon ever recorded in history, since they've been able to actually make these measurements of wind speed, and that's an extreme. This vortex breaking down and sending this cold air down, that's another extreme. They're having near record surf hitting England. That's another extreme. I have to get used to it.
It's going crazy. It sounds like a movie.
Yeah, it sounds like a movie, but we're living it, and we're experimenting on the planet in a way that hasn't been done before. I don't know that the extremes are unprecedented in the entire lifespan of the Earth, but it's certainly something that we humans aren't used to.
Yeah, in our years on the planet, anyway, in our lifetime.
Yeah.
So we've had some news about, the fact that now, for reasons that maybe you can help me understand, there's additional ice in Antarctica and also in the Arctic, just right now, been noticed. And so I thought we were in global warming, but we're not. What happened?
Well, it's interesting. You get these weird extremes. Now, you can get an additional ice in Antarctica because there's additional moisture in the atmosphere, which happens in parts of the atmosphere warm. Then the moisture goes into the atmosphere, moves towards the poles, snows out. And so now you'll have the ice thickening, potentially. But the other takeaway about the Arctic is that we've gone from a year in which we've recently had unprecedented low ice cover in the Arctic now to having extra ice. This is an example of the extremes that we're going to be going through as the climate changes. Next year, for all I know, the ice will all go away again, or it's just going to be a little unpredictable.
Could we be operating under a false premise here? Could some of those Southern senators who oppose the notion of climate change be right? Could this just be, just a fluke, and we're going to return to normalcy in almost no time at all?
Well, unlikely.
It's not a serious
the preponderance
question.
of the vast majority of the weight of the scientific evidence is that we're in a long-term warming trend, and this is actually despite the fact that we're actually due for an ice age. Why
do you say that?
The Milankovitch cycles, every 100,000 years, the planet seems to go to a place in its travel around the galaxy and around the sun where we have ice ages, and we're due for one. And it seems that humans, with thousands of years of slash and burn agriculture and forest clearing and then the Industrial Revolution, may have actually choked off an ice age, which is the good news. But the bad news is we're overdoing it. We're going beyond choking off an ice age to creating an era of global warming that's warmer than any time we have ever experienced as a species, any time in the last several million years. So.
Does that mean, Mike, that that when we're finished with this global warming business, we go through whatever process, and we can talk about what that is, that we're ultimately going to have an ice age anyway, no matter what happens?
We'll eventually have an ice age. We'll eventually have ice caps coming down through Canada and into North America again. But it could take 6,000 years for the carbon we put in the atmosphere to finally precipitate out, become biomass or the shells of marine organisms. We may have made a lot of those marine organisms extinct and prolonged the process in the meantime, though.
But those organisms could come back.
They could, yeah.
Because there's carbon there for them.
Right, they can start making, the problem with the carbon is that they use the carbon to make the shells, but they also need the ocean to be alkaline to keep their shells from dissolving. So there's some animals that can deal with it and some that can't. So we're also changing ecosystems wholesale in a way that we aren't used to. We don't know how to predict, and we certainly don't know what species will arise to fill the niches that we're making vacant, right, with these extinctions.
Well, when you talk about extinctions, and you talk about the difficulty of existing life in the planet and the extinction of some life on the planet, and the need to have alkaline oceans in order to make the carbon into
calcium carbonate, and
all the components of their life cycles. Are we heading toward an extinct planet?
Oh,
are we heading toward a barren wasteland with no life or with very limited life? Is that where we're going?
Well, no, I don't think so from what I've seen of the evidence. And I think the species can adapt. I mean, we're going to have to write off some coastal cities. Manhattan will probably build a seawall around, but we may have to give up on Miami. We have to give up on Venice, sadly. We have to give up on a lot of cities.
You mean the restaurants too?
Yeah, I can't get that Cuban sandwich in Miami anymore, but maybe
the seafood in Miami, Italian food in Venice.
Yeah. And sadly, it's a lot of the countries that are just the worst equipped. That Bangladesh, Kiribati, they're the ones that are going to suffer the most. Low-lying areas.
That's interesting.
Yeah. The first world will move inland. Here in Hawaii, we'll move upland. We probably won't abandon Waikiki, but we might abandon the North Shore.
Yeah,
And
I can imagine.
Tennessee take that. So,
well, let me ask you one more. I don't understand it question, and that is the Russian ship that was being used by the Australians to do research at Antarctica. All of a sudden, it gets icebound.
yeah.
And it sounded like that was a very fluky, set of circumstances. Because remember, it's summertime there now. It's the warmest time of the year. All of a sudden, by surprise, they're locked up and they have to be flown out, person by person.
Yeah.
What happened?
Well, I don't know. I don't know whether that's just a normal example of the flukiness in the Antarctic in general. The Antarctic ice pack is very unpredictable in general. I mean, could be that there's extra ice in the Arctic Ocean because the glaciers are flowing faster into the sea because of global warming. It could be that the winds had a different pattern, just happened to push the ice, towards these ships, and then it reversed and pushed it away, and now they're all free. Can you imagine the polar explorers doing this in the last century before aircraft, when you couldn't have even conceived of helicoptering them off? And those 70 scientists and 20 crew members would have been possibly could have all perished.
Yes, because if staying the season doesn't work in the summer.
Yeah.
It's already the summer. There's no summer coming after summer.
There's no summer coming after this. Yeah. And so we're fortunate that we have the technology of icebreakers to go free these people and get them off. And but you got to admire the bravery of Shackleton and Byrd and Scott and the people that have done this Arctic and Antarctic exploration, some of whom just perished.
Yeah.
I mean, Munson won the Great Race to the Pole, Scott lost, and he died.
Yeah.
And lost all his men, too. So.
And even those who survived lived a very hard life there.
Oh, yeah.
I mean, day by day it was hard.
Yeah.
So,
sorry.
Well, while you take that call, why don't we take a short break? That's Mike Deweert. He's our chief scientist, and are we glad we have him as our chief scientist here at ThinkTech? And today we're talking about storms of our grandchildren here on Science Thursday, which it is actually Thursday.
It is Thursday.
Here on ThinkTech Talks. We'll be right back after this break.
Aloha, I'm Nicole Horry for ThinkTech. For nearly half a century, the Hawaii Foreign Trade Zone No. 9 has brought the benefits of the Foreign Trade Zone program to Hawaii businesses and entrepreneurs. DBET, the Department of Business, Economic Development, and Tourism, operates Hawaii's Foreign Trade Zone program to encourage international business and economic development. The Foreign Trade Zone's mission is to increase the amount of international trading activity in Hawaii, thereby providing employment opportunities for the residents of our island state. For more information, see ftz9.org. I'm Nicole Horry. Mahalo.
Okay, we're back. We're live. I'm Jay Fidel. You're here on ThinkTech Talks, specifically on Science Thursday with our chief scientist, Mike Deweert. Remember that Mike is going to take his own show and be a host starting in a week or two here on Thursday at the 1 to 2 block, talking about all kinds of science you should know about in the 21st century. You can hardly not know about science. Today we're talking about storms of our grandchildren, and that's because it's a book.
Yeah, I started reading this book by James Hansen, he calls it Storms of My Grandchildren, but I think a lot of us have grandchildren. And James Hansen, you may recall, was a scientist that worked for NASA, NOAA. He got in a lot of trouble in the Bush administration because he spoke truth about climate change and what we're doing to the planet with our unconstrained carbon emissions. He's now working for a not-for-profit and trying to get the word out and with some sense of urgency about how fast climate change is happening in a way that is actually faster than we had predicted in some ways, although unpredictably fast. I mean, as you pointed out, we've had extreme warmth on the East Coast and extreme cold, within weeks of each other. And so it's we're creating a chaotic kind of climate regime that we're moving into that we don't know what's going to happen. We can't really model it accurately enough yet.
We got to do a lot of study. In fact, very interesting. On Tuesday this week, we had two fellows who were researchers at the School of Geography.
Yes.
Do we talk about that? And they made a study based on temperatures.
Yeah.
Why not?
Yeah,
Geography.
right,
why not?
Right.
showing that by, I think they said by 2047, every year would be warmer than the previous one. There would be no more years that were colder than the previous year.
Yeah,
And that's pretty scary.
It is scary, yeah. And when I saw that, I read the study, and when I read it, I thought, well, this is really on average only a few degrees centigrade. And I was like, well, they're making a big deal about it. But then I start reading other stories about how the mangrove swamps are moving north in Florida into areas where they're not native, not established. And the reason the mangrove swamps are moving north is that a few degrees of change means that the frost doesn't come anymore to those areas. And a few days of frost a year is enough to discourage mangrove swamps. Ah, now the whole ecosystem is changing, and yet the temperature doesn't seem that different to us, but to the plants and animals and things that have to live in it without that extreme cold, it's completely different. Earthworms are moving north into forests where they haven't lived, and they're changing ecosystems there in the northern United States and Canada. So we got these wholesale changes in ecosystems that a few degrees of temperature is enough to flip the switch. And so these guys, I think, are onto something here. You know, how a new climate regime is what we're going to be facing in our own lifetimes.
You know what's really scary? I mean, everybody can, you know, like walk north of the mangrove and it's okay. They can get away from that.
Right.
But it strikes me that there's a whole new sub-microscopic world out there. And all those, you know, antigens out there are going to be able to, they're going to be affected by the change in temperature too.
Sure.
And infections, you know, bacteria, virus, who knows what, all going to be affected by this. And I don't think it's going to be good because cold usually freezes them, stops them, makes them immobile. Now warm is going to activate them. Yeah,
well, yeah, and it works both ways because cold, dry air tends to dry your mucous membranes and makes you more susceptible to infection. And warm, moist air tends to do the opposite. Yet warm, moist air encourages mosquitoes and fleas and other disease vectors. And we could see dengue fever in Philadelphia. And they used to have yellow fever in Philadelphia before they killed all the mosquitoes. Well, we could see that coming back as the mosquitoes that carry these diseases become more abundant farther and farther north. I mean, we've seen dengue here. It's not endemic here, fortunately, but it could become more common here.
So when we talk about not knowing everything about it, we're really that's an understatement. We don't know anything about it because it hasn't happened yet.
We know that the trend is, on average, globally, is warmer. We don't know the details of where it's going to have impacts in terms of where the climate will become drier or wetter, where the climate will become temporarily colder or temporarily warmer before a long-term pattern sets in where it's stable. We don't even know if it's ever going to become stable within the time that our civilization can foresee. I mean, the carbon dioxide and we already put in the air could last thousands of years before it precipitates out.
So is this guy Hansen, James Hansen, who wrote this this book, Storms of My or Our Grandchildren, is he a scientist?
Oh yes, a very well-respected climate scientist. He did this for many decades at NASA, leading research efforts there. Got into trouble because he spoke the truth at a time when the administration in power didn't like the truth, didn't like to hear it.
That was that administration for sure.
Yeah, but he's also surprisingly annoyed a lot of people who consider themselves liberals because he said that the urgency of getting off carbon is so great that we should be moving to nuclear energy. And it means breeder reactors.
Even taking the risk.
Well, the risk is, so you have a risk of a localized problem with nuclear energy, perhaps, like Fukushima. And that was just a lot of boneheaded errors that led to that, an accumulation of errors that they shouldn't have made. You know, they should have. The Japanese knew historically that great earthquakes could happen in that area. They had monuments marking high water mark from hundreds of years ago. They put the backup generators where they could be flooded easily, and so the backup power that was going to keep the fluid circulating in the reactor and keep it from melting down went out. There was just, so yes, we got to learn things about that, and we can do it more safely. I mean, the French get 60% of their energy from nuclear. They've never had a Fukushima disaster. They've never had a 3 Mile Island disaster. Practice makes perfect, and especially if you have a democratic society that really pushes safety, and yet with reason. So,
You know, I had a kind of revelation a few years ago, maybe 10 years ago, when I went on, I think it was the Cheyenne, which is a nuclear sub at Pearl Harbor.
Oh, yeah.
It was an attack sub.
yeah.
And I did that in connection with the Hime Maru incident. It was a sister ship of the Greenville, which is the one that brought him down. And I walked
That
through
was
the.
terrible.
Say?
That was a terrible incident.
It was awful.
Yeah.
And it sort of gave you a reality test on how these subs really work, both in terms of equipment and management. But I walked through the sub, and what I didn't see, Mike, I didn't see PCs.
Right.
I thought, your life and my life and everybody we know here in Bishop Street, they got PCs everywhere.
Right.
They got multiple PCs per capita, home, office, every in the middle. But now, mind you, this has got to give them, it's 10 years ago, or 2001, and there weren't a lot of PCs at all. And I'm thinking, wow, has the nuclear game changed? Even in the last 10 years. We didn't have any PCs back in '79 with 3 Mile Island. Now everything is computerized. We have software that does everything about everything. So you have to assume that the nuclear business is a lot more sophisticated at every level because of that. A new nuclear plant is going to be a very sophisticated piece of gear.
Yeah, it will be a sophisticated. It'll have to be, because we're going to have backups to the backups, and we've learned a lot from our experience. And we're reluctant perhaps to learn from the French, but we could learn a lot from what they've done successfully. And we're going to have to learn, because carbon is the #1 threat, the pollution, and we're not going to give up energy. I mean, James Hansen is right when he observed that our appetite for energy is voracious. We're not going to easily go back to the energy consumption we had per capita before the Industrial Revolution. We're not going to go back to the 1700s. So we're going to have to start...
Not with this population.
and certainly not with this population. The average American, you look at the electric bill for your house and say, oh, maybe I use 20 kilowatt hours a day. Well, you don't. You use 100 kilowatt hours a day, because all the stuff, the pens, the iPhones,
computers,
the car,
whatnot,
computer. 100 kilowatt hours a day is 5 times what my roof can put out covered with solar panels.
Mike was one of the early adopters of solar.
So, so when we're talking about taking Hawaii clean on solar, we could probably meet our residential needs pretty easily. With a stretch, we might meet our transport needs. But the third of the energy for commercial is going to be hard to get. Not impossible, perhaps, with solar and wind, but hard. Maybe harder than we want to do, and so we're going to have to look for other alternatives. Conservation's a big one. We can use less. We also need to use it smarter.
So, talking about public information for a minute. So here's a softcover book. It's published by a big publishing house, Bloomsbury.
I've never heard of them. I bought the books, but
can't be a small one. So where'd you get it? Amazon?
I bought it at Amazon.
Okay, well,
and so I get on my computer, and they fired up the Amazon server bank in California and consumed a whole bunch of carbon fuel in the process. And then they put it on a nice jet plane from the mainland, and it shows up at my doorstep 3 days later. So
the cost is greater than it seems to be.
Yes, so the carbon in the paper in this book probably is about the same as the carbon used in the fuel to make the book and to get it here.
Next time you'll just get an electronic
get
version.
it online. And,
so what is this book telling us? I mean, what's the message, and what's the breadth of the book? What can we learn? And I guess the big question is, should I, as a non-scientist, should I read this book?
Well, I think everybody should read this book. He gets a little technical, and I've only gotten a little bit ways through it. He's a little technical, but he tries to bring it down to a level that non-scientists can understand, because he really wants to get the word out about this is a pretty urgent problem. He talks about saving the species in some of the words here. I don't know that we're in that regime where we're facing an extinction threat for ourselves, but we're going to have horrible problems on this planet socially and economically unless we really learn to work together as a planet.
That's what he's describing here. He's telling you the worst case analysis.
The worst case analysis.
Now this raises the subject that I wanted to ask you about. That is public information. I remember being at a dinner at the time that the Al Gore movie came out, Inconvenient Truth. But that's not that long ago. 10 years maybe.
10 years.
maybe. And I stood up from, the friends who we were having dinner with told us that they had just seen this movie in the afternoon.
Yeah. Yeah.
And I said, I must see the movie.
Right.
And I skipped dessert.
Right.
And I stood up from the dinner table, I left them all,
Wow.
and I went to the movie theater. I had to see that movie right now.
Yes.
And it was a turning point, a profound turning point for me.
Yeah. Yeah.
And I felt that now maybe I had a handle, and maybe I knew a little something about what was going on, and I accepted the movie, although the movie was being criticized at the time.
Well, yeah, it was being criticized for how much it was trying to scare people, but it requires that's a problem with our species. We don't live long enough to be scared about something that's going to happen in 100 years.
Right.
We live long enough to be scared about something that's going to happen in 10 years.
Hence the reference to the grandchildren.
Yes. Yes, the grandchildren.
People don't really care about their grandchildren. Well, sorry, they don't really care. Maybe the Chinese too. They look down multiple generations.
Yeah.
But here, so you see this movie, and it is somewhat alarmist.
Right.
Okay.
Right.
But that's not the main channel. Most materials you see, I think, don't you agree? They hold back. They don't want to alarm the public.
Right. They don't want to alarm the public, and that's good and bad. It's bad because people don't take action unless they're alarmed. It's good because you get alarm fatigue. We just tune it out, and we're seeing that in a lot of, I think, cases that people are just tuning it out because they don't want to think about it. They got too much now going on in their lives, with their daily commute, their kids, the college tuition, whatever. So as a society, we got to find a way to have the discussion, get the message out, make sure people understand, that this is the time we have in the next few decades to either prevent the worst consequences of global warming or accelerate them and make future generations even more miserable. We have the time and the opportunity now to change the course of the future.
How would we do that?
Well, we would have to use less energy, and
meaning everyone. Because if Hawaii was really good, really, crossed the T's, dotted the I's, wouldn't have a big effect on the world.
Well, that's true, but we could set an example. I mean,
maybe.
If we can't do that, who can?
Lead by example.
Yeah, for example, like our street lights. You go over to Molokai, you look at Oahu, the lights shining up in the air, useless. We could do more effective use of energy for things like lighting. Cars, okay, so I drive a Prius and I drive it to work every day. So I may be using half the gas I used to use, but I'm still driving my car to work every day. Better mass transit, making the commitment to have transit at times and places where it actually work for people. That could help.
Yeah.
Paving over fewer of our forests and watersheds and farmland with concrete, which is very energy intensive, and doing more ecologically sensitive
damage at the same time. So you're hurting yourself on two levels.
Right. You got less farmland locally, so now your food has to be imported with a lot of energy from somewhere else.
Yeah.
And that's so being more conscious of the energy we use. Some of the symbols going through your house, replacing all your incandescent bulbs, which you should get rid of anyway because they're expensive to run, with fluorescents and LEDs. That'll help.
Yeah. We just had somebody from the, his name was Jeff Chang from the Airports Division yesterday, sitting in that seat. And the Airports Division is putting in a huge project. I want to say $150 million project to upgrade their bulbs and other energy efficiency devices, and their calculations that they're going to save well more than they're putting in.
Oh, absolutely.
Over a period of time.
Absolutely.
So they really get it.
Yeah, if somebody gives you an incandescent bulb for free, well, use it as a fishing float, paint it, use it as a Christmas ornament, whatever you do, don't screw it into a light socket, because it's going to cost you more money than paying $10 for an LED would even.
That's Mike Deweert. He's our chief scientist. Every company, like ThinkTech especially, ought to have a chief scientist. We're delighted we have a chief scientist. And today we're talking about the storms of my grandchildren, or our grandchildren, which is a book written by James Hansen, who's a scientist, here on Science Thursday on ThinkTech Talks. We'll be right back after this short break.
We want to thank our underwriters. Hawaiian Electric Company and its affiliates Maui Electric on Maui and Hawaii Electric Light Company on Hawaii Island are deeply committed to the communities they serve.
Galen Ho is a senior executive of BAE Systems, a global defense, security, and aerospace company.
The High-Tech Development Corporation, the state's leading technology agency, attached to the Department of Business, Economic Development, and Tourism.
Castle and Cook Hawaii, with a time-honored legacy that spans more than 160 years and revolves around its mission of investing in Hawaii, creating communities, and providing for the needs of our state.
Hawaii Gas, formerly the Gas Company, a proponent of the Liquefied Natural Gas Initiative, helping Hawaii achieve its transition to clean energy and a better energy future.
Collateral Analytics, a Hawaii-based tech company empowering the real estate industry with greater and faster access to the tools and data they need to make better informed property investment decisions.
I'm Nicole Horry. Thanks so much for joining us on Think Tech.
I'm Maria Kashem. See you next time.
Okay, we're back. We're live. I'm Jay Fidel. Here you are at Think Tech Talks. We're talking Science Thursday with Mike Deweert, our chief scientist here at Think Tech. It's very important that we have a chief scientist. And if you want to, if you want to do any Twitter, you can tweet us at Think Tech High, and we get your questions. And my goodness, we can answer them. Mike can answer any question anyway.
Well, I'll tell you if I can't. So, yeah.
So we're talking about cars, and the big problem for Hawaii is we import all this fossil fuel. We've been into that for a long time. We didn't have to be, but we got into a rhythm of it, and that's what we do. Yeah. And the biggest part of the fossil fuel we import is not necessarily what runs the generators. It's what runs the cars, because we have so many cars. We have never limited the cars, and we've been selling cars like hotcakes since statehood. And there's cars everywhere. With 5 cars in every chicken pot, whatnot. Okay, and so. Are we really being responsible? Can we be a world leader in energy? Can we show the world how to do this if we're still running highways chock-a-block with fossil cars?
It's hard to say that we're world leaders. I mean, we used to have a railroad that went from Waikiki to North Shore. Where is it now? It's buried under the freeways. I went to Sicily, and they have a railroad that goes all the way around the edge of the island. Now, Sicily's a big island, bigger than Big Island. But why don't we have a circumferential railway here? Why don't we have a railway that goes through the middle of the island, up through Mililani to the North Shore? It would be much more energy efficient than what we're doing now, which is everybody gets in their cars. So how do we encourage people to get in their cars? How do we really encourage mass transit? The railroad from the west side to the east side is a good idea, but it doesn't go to the university where the traffic goes. It doesn't really go to Kapolei, where the people live. It sort of stops in the middle of nowhere, and they're building a new subdivision there that's, we need housing, but do we need to put it on farmland? Why can't we put it where there's densify the urban core, which is some of the things we're trying to do. We should be making the urban core a little more dense and then encouraging mass transit.
Even the electric cars, which I think electric cars are good. I also think hydrogen cars are good. But electric cars, after all the hoopla over electric cars, there are 1,800 electric cars in the state out of, I don't know, what, a million.
Something
a million.
like
It's really a pathetic number. That's 1% and change.
Well, bad or good. So if you were to say to take your gasoline car that gets 20 miles to the gallon and just throw it away, put it in the landfill, and buy an electric car, well, are you really helping things? If that it takes as much energy to make your electric car as it did to make that gas guzzler. And the energy that car uses is just about equal to the energy you're going to put in it in terms of gasoline for over its lifetime. So you've essentially thrown away a whole car's lifetime of gasoline consumption by putting that car in the landfill. Is it a gain? My philosophy is drive it until it won't drive anymore, and then buy the electric car. Use it up, and then buy the next thing that's more energy efficient.
Right, because we spend so much energy making the thing in the first place.
The embodied energy in the stuff we buy is amazing.
But, how do you change the behavior of billions of people? How do you develop political will that is global on this? I mean, it's mission critical now. And if we don't have political will that's global, we won't be able to do the job. And if we don't do the job, we're going to have the bad movie.
We'll be living in the bad movie.
Living in a bad movie. And anything could happen. But let's assume, just for this discussion, and I don't want to sound alarmist, but let's assume that we don't do anything.
Yeah.
That we just cruise on. Nobody takes it seriously.
Yeah.
It's burdened by politics and bad management.
Right.
What's going to happen to us?
Well, what'll happen? Well, we'll have a lot more migrants from Mexico coming up because Mexico will become uninhabitable in large areas. The Chihuahuan Desert, Sonoran Desert will become uninhabitable. Arizona will probably have to abandon it because the Colorado River will dry up. Are we going to abandon Phoenix and Tucson? I don't know, but they'll become places where you just can't live, outside during the daytime a good chunk of the year, and there'll be no water. Policymakers there have been nudge, wink, winking, giving 100-year water certificates. In Tucson, to build a house, to build a new housing development, you have to certify a 100-year water supply. They know they don't have it, but they've been giving out the certificates anyway, saying they do because they think they're going to get it from the Colorado River. The Colorado River is already oversubscribed if you look at the treaties. We've promised more water to all the states and countries along the river than there is in it. So
it's the election cycle.
Yeah, exactly.
As long as the thing doesn't fall on your head during your term of office, you're okay.
Exactly. That's the problem. It's the short-term thinking. And how do we cultivate a longer-term thinking? Well, it's education. I mean, we're going to lose a lot of coastal cities, and we're going to see population migrations. I mean, when Bangladesh goes underwater, those people are going to move somewhere. India may not want them, or die, and people don't want to die, so they will be desperately moving. If they can, they'll vote with their feet and go inland.
They're capable of violence.
Yeah,
There's been in the paper, there's plenty of violence in Bangladesh right now.
Yeah, economic famine will lead to war. Water supplies will lead to war. We will have a more politically unstable world, a more food insecure world. When crops start failing in the Great Plains because the rains fail, or if there's extra hail, climate extremes that we're not used to will just cause us lots of problems. Will it end our civilization? Probably not.
But there'll be a lot fewer of us.
There could be a lot fewer of us on the planet as a whole. I don't think so. I think the world population will still grow, but there'll be places where it's increasingly desperate and miserable.
Yeah, well, let's say that we have some technology.
Right.
And although we can't change the surface of the Earth, and we don't have that kind of technology, but we can, what do you call it before? Resilience technology.
Yeah. So we can build our cities to, better adapt to changes of climate. Like you can build your home to need less energy to cool. You can build your transportation system to be less vulnerable to floods. We can move our airports inland, away from the tsunami zone, away from the hurricane flood zone, those kinds of things. We can engage in geoengineering, but that's a different kind of experimentation. They've been talking about.
We haven't done that much.
They've done some limited experiments putting iron in the ocean to try to encourage plankton blooms, and they had inconclusive results, whether you could encourage enough plankton bloom to take the carbon out of the air.
Sounds like messing with Mother Nature.
Messing with Mother Nature, yeah. They've talked about pumping sulfur dioxide into the stratosphere to reflect the sun's light back into space and to cool the planet. Maybe it could work, but where would you pump it? How would you predict whether the local extra cloud of sulfur dioxide causes a local cooling, it causes a change in the wind pattern, it causes some catastrophe you hadn't foreseen? We don't want to have to go there if we can avoid it, if we can stop making the problem worse, start reducing our fossil fuel use. We may have to go more on nuclear fission.
But even if we
will eventually go on nuclear fusion, which will be cleaner.
A lot of people say that, scientists anyway.
Yeah, it's been 50 years away for 50 years, so.
Right, exactly. Well, but even if we decide we have to take these Herculean steps, those are big projects. They're expensive projects. They require a lot of collaboration. They require, some people are going to be very inconvenienced by them, and they're not certain because we haven't really figured it out. So the result is we're going to have trouble getting political will.
Yeah.
And people are going to kick the can down the road, and then, whoop, they're going to get the full brunt of it.
I wish there was a science of predicting how to make politicians do the right thing for the planet.
This is we're going to, what you're drawing a picture And we'll get to this after the break coming up, but you're drawing a picture of a need for a new mindset.
A new mindset.
And maybe new elements, new approaches in government. And you know, action by large groups, collaboration on a scale we've never seen before in order to survive.
Yeah, absolutely.
On that happy note, we're going to take a break. It's Mike Deweert, Chief Scientist of ThinkTech. Every organization, especially ThinkTech, has to have a chief scientist. Here you are in ThinkTech Talks on Science Thursday. We're talking about storms of our grandchildren, which is a takeoff on the title of this book by scientist James Hansen. I'm Jay Fidel. We'll be right back in 1 minute.
Aloha, I'm Nicole Horry for ThinkTech. For nearly half a century, the Hawaii Foreign Trade Zone No. 9 has brought the benefits of the Foreign Trade Zone program to Hawaii businesses and entrepreneurs. Deweert, the Department of Business, Economic Development, and Tourism, operates Hawaii's Foreign Trade Zone program to encourage international business and economic development. The Foreign Trade Zone's mission is to increase the amount of international trading activity in Hawaii, thereby providing employment opportunities for the residents of our island state. For more information, see ftz9.org. I'm Nicole Horry. Mahalo.
Okay, we're back. We're live. I'm Jay Fidel. Here we are in ThinkTech Talks on Science Thursday, which is going to become a program all of its own with Mike Deweert as the host in a couple of weeks. Mike Deweert is our corporate scientist, our chief scientist here at ThinkTech. We love having him on the show, so much so that we're going to have a regular Science Thursday with Mike going forward. Today we're talking about the storms of our grandchildren, which is, I mean, there's so much policy in there in that statement. You know, you really wonder if we're thinking properly about our grandchildren. And we've come now, you know, in the last part of our show to talk about maybe the most interesting part of it all. And that is, you know, the idea of the mindset. We as a race, we as a, you know, global community, we're going to have to develop another kind of mindset. How is that going to work?
Well, we will have to have a long-term perspective, and it's not impossible. Our species has done that. In England, when the British king built the new college, I can't remember which king it was, he built something called the New College at Cambridge hundreds of years ago. And when he built the new college, they planted a forest next to the college, a forest that wouldn't be mature and ready to harvest for timber for 300 years, because that's when they figured the timbers would start having to be replaced. They planned hundreds of years ahead for this. And we're not, the Chinese have planned hundreds of years ahead in their past. We are capable of looking ahead hundreds of years and planning for that, and being concerned with what happens to the people who come after us. And we have to be. We have to move to that kind of a mindset. Too often people are like, well, I'm going to die in 70 years. I don't care what happens after me. Well, okay, you can be that way, but we need to cultivate a more positive, optimistic, long-term outlook to save the planet, because none of us...
How do we do that?
How do we do that?
Yeah. Well, I know this is, you know, beyond pay grade for both of us, but you know, how do we do that? How do you change the way people say? I think in the Industrial Revolution and now the, you know, the electronic revolution, if you will, people are more into possessions, more into their old kuleanas. They like their stuff. They're going to think about their stuff first. They spend all day thinking about their stuff. They don't think about the community.
Well, but we've had greedy people forever, you know, just thinking about their stuff.
Fair. I wouldn't argue that.
So the thing is, we've been spoiled somewhat in the last 100 years because energy has been so cheap. We may whine about $4 or $5 gasoline, but it is cheap.
$10 in the UK.
Yeah, and that is cheap compared to what it's doing to the climate. We are so used to being able to go out and buy a $5 shirt, $10 pair of pants, $3 socks, but our ancestors had to harvest that cotton. They had to spin it into cloth. Somebody had to dye the cloth, and it was usually somebody you knew. So part of what's going to happen is we're going to have to start learning how to value our possessions and invest in possessions that will last us, not possessions that we throw away after a few days.
Planned obsolescence.
Planned obsolescence is just poisonous for our society and for our outlook on the future. I hate to say it, but the only way to make that happen may mean to force energy prices to rise. You know, they're low right now because we're not folding into the cost of energy what the energy is doing to our planet.
Right, which we will have to pay.
We will have to pay one way or another. But right now, so you go out and you buy a piece of plastic junk that may add carbon to the air, and you throw it away, and that carbon may, in 100 years, cause a catastrophe. You're contributing to that. How do you make that piece of plastic junk cost as much as it's going to cost to fix the mess we're making? And that's something that our United States are having a very hard time. We're talking about carbon taxes, which they do have had in Europe. They tried it in Australia. It looks like the politician who put that in is going to be kicked out now, has been kicked out, I think, and they're going to change the law. They've been trying to put a price on carbon, and it's we need to make it, if we can't put a price on it, we need to make it unacceptable socially for people to waste things. You've got to value the things that you have enough that you don't waste them. You don't consider everything disposable. And how do we cultivate that mindset of valuing the stuff that we have and only buying the stuff that we want to keep?
Well, the other side of it, this is the drear side, is that we're going to have to get used to, we're going to have to get off the assumption that the weather is going to be reasonable, even here in Hawaii.
Oh, yeah.
We're going to have to get off the assumption that if we build a city in a given location, it's going to stay there.
Yeah. Oh, yeah.
Or that the mangroves are not going to move north. Things are going to change as they have never changed.
Yeah.
And we are going to have to change with them and deal with it.
Yeah, here in Hawaii, we're talking about, say, 5 degrees of climate change temperature. I think, oh, that's not much. I can deal with 75 instead of 70 in the winter. Well, that 5 degrees greatly increases the chances of hurricanes now. Usually the hurricanes fizzle out before they get here because our ocean is relatively cold compared to the ocean in Mexico where they spawn. Well, once our ocean warms up to where it's not that cold, then they'll get here more often. And so we have to be prepared for that, be ready for that. We have to be ready to lose the North Shore, to sea level rise and erosion.
And move on. We'll have to go somewhere else.
Yeah, have to go somewhere else.
You can't make the assumption that Waikiki is always going to be there, or New York City is always going to be there, or Miami is always going to be there. No, maybe not. And we have to move inland, and a lot of people suffer. The economy will suffer. How are we going to pay for those costs?
Yeah, we got to start planning for it, and the longer we delay, the harder it's going to be. I mean, we should be. Fortunately, we can move upland here in Hawaii. We have enough topographic, like Florida. Average height of Florida is 100 feet.
Yeah.
Florida's gone in a few centuries.
Wow.
Hawaii, the average height, 1,000 feet. We're going to be able to move inland here. We've got to start planning for that, making it easier to move inland and instead of harder. So
different places are going to move at a different rate. Different places are going to have a better, what did you call it, resilience.
Yes, resilience.
And the interesting thing is that up till now, the electronic revolution, the scientific revolution, if you will, you're right in the middle of that, has been always, things will always be better tomorrow than they are today. I think in the future, there's going to be a little oblique on that, and that is that we love our technology. Maybe it can save us.
And it's a choice. We can still make tomorrow better. We still have that opportunity. But it's our choice to make it better, and we as a society can certainly choose to make it worse. But we have an opportunity still to make tomorrow better. We can do the things, we can use more energy efficient technology, we can develop more conscientious forms of energy that don't ruin the planet. We can work to build a society where we do actually cooperate with each other instead of always fighting each other over limited resources. I mean, these islands, James Thoreau said, these islands are big enough to share, but not big enough to fight over. There's not enough to fight over, but there is plenty to share if we work together. So,
you know how we're going to do this, Mike?
Yeah.
Raising public awareness.
Yeah.
We're gonna work at that every day, and we're certainly going to work it on Thursdays.
Yes. Yes, indeed. Yes, indeed.
At 1 to 2. And Mike is going to take the show called Science Thursday every Thursday, 1 to 2, and raise public awareness about science in general, including but not limited to this. To try to make people understand the changes that are happening in the world, especially our world in Hawaii. Thank you so much, Mike.
Thank you.
Mike Deweert, our Chief Scientist.
Thank you, Jay.
Aloha.